Hi everyone. In this lab, we investigate the emission spectrum of hydrogen. So let's start by reviewing the theory behind the emission spectrum. Okay? Okay. The most important thing is that the energy levels of the hydrogen atom are quantized. And when the atoms make a transition, let's say dropping from a more energetic state to a lower energy state, the energy can be released in a photon. And the energy of that photon has to match the energy difference between the energy states involved. We've talked about this in class. Remember that the energy states for the hydrogen atom can be written as minus E sub 0 divided by n squared, where n is the quantum number, 1, 2, 3, and so on. And E0 is the binding energy of the hydrogen atom, which Bohr's theory predicts should be equal to mass of the electron times the electron charge to the fourth divided by 8 E naught times Planck's constant squared. Okay? When we look at a transition between two states, the energy of the photon emitted should be equal to the energy difference between the initial state and the final state. And this can be written as E0 times 1 over NF squared minus 1 over NI squared. Okay? So that's the prediction that we're going to be testing today. First, we want to know whether this model can predict what we see. And secondly, we want to know whether, if it does, whether E0 is accurately predicted by this set of constants. Okay, now when you do your measurement today, what you're going to measure is a spectrum. That is, you'll end up with a graph of intensity versus wavelength. And what we expect to see for a gas discharge lamp like the one you'll investigate today are a series of sharp emission lines at various wavelengths. Okay? And for us, the important information is the location of each of these peaks, which I've labeled here as lambda 1, lambda 2, lambda 3, and so on. And that should all be well and good. And the only thing that's a little bit tricky about this experiment is that the emission lines don't come with labels. So in particular, we don't know, until we've thought about it a little bit, what the initial state and the final state of the transitions are for each of these lines. And so that makes it a little difficult to compare the theory to the model, to the experiment. Okay? All right, we'll go ahead and do the lab, and then we'll talk about analysis afterwards.